Hello, people. Joshua is going to erase that nonsense message. Thank you, Joshua. Today we are learning about how to solve an exponential and a logarithmic equation. And I am without my pen. Where did that thing go? This is no bueno. Is it back there, dude? Under that blanket, maybe? Oh, over here. Found it. Good job. Sorry, people. That was like 1 minute of nonsense. Really sorry about that. But here we go. I mentioned to you before, earlier in the lesson or earlier in the chapter, that your ability to go from logarithmic form to exponential form was going to be crucial in your success in being able to solve these equations. And herein lies one of those examples. So I'm going to show you how to solve. And basically this is exponential form. I know that because the exponent has a variable. And I know that it's not logarithmic form because there's no log in the expression at all. So my job, if you remember, I always like to rely on my 2 to the third power equals 8 example, because I can say log base 2 of 8 equals 3. So this is exponential form, and this is logarithmic form. Okay? So remember the whole like circle thing, 2 to the third power is 8. So if you keep that in mind, when I look at this and I want to put it in log form, I'm going to say log base 7 of 3x, sorry, 20 equals 3x. Something like that. Right? That is how we're going to do this. But what you're going to see right away is that you can't solve it because at this point you can divide by 3. Cool beans. But one of the problems that you're going to come across is, how do I know what log base 7 of 20 is? Because you can't put log base 7 of 20 in your calculator, right? So we're going to teach you how to avoid that in the future with the change of base formula. But right now, I want to approach this problem in a slightly different way. So what if, instead of doing that, what if we were to take the log of both sides? Because we know that the log, that guy is moving because Joshua is moving it. We take the log of both sides because the inverse of exponential is logarithmic. So if I go log of 7 to the 3x power equals log of 20. And you guys remember that if I don't have a little number right here, a little subscript, we assume that it's a 10. So I take the log of both sides, and then what I can do is I can use my properties of logarithms, in this case the power property, because my exponent is up here, and it will move to the front, and it will be 3x times log 7 equals log 20. And then to divide by 3 and log 7, divide by 3 and log 7. The 3's will cancel, the log 7 will cancel, and I'll get x. Log 20 divided by 3 log 7. Go to my trusty calculadora, and log 20 is approximately 1.301, and 3 times log 7 is approximately 2.535. And if I divide those two results, then I'm going to get I have no idea why I just said 5,000 times, but it's okay. You're going to get 0.3665. And that is your solution to this logarithmic equation. All right? So there we go. I didn't get the same answer. Why didn't that I got earlier? I think I did something weird with the calculator. Hold on. Log 20 divided by 3 times the log of 7. See? This is not the right answer.
It's 3 times
No, but I did that, but for some reason I didn't type it in right or something, because I didn't put it in parentheses. So make sure that you put 3 log 7 in parentheses. And so this time I get the actual answer I got earlier, which is the right answer, 0.5132. That's the right answer. So this is correct, but for some reason when I typed it in the calculator, it gave me some weirdness. But this is the right answer, 0.5132. So I want you to try these little guys. Take the log of both sides. I will help you a little bit with this one because it's a little bit, might look a little tricky to you. This is in parentheses here. But again, if you take the log of both sides, it's going to be log 3 to the x plus 4 power equals log of 101. And then the entire exponent is going to go in front, and you're going to have x plus 4 in parentheses, keep it together, times log 3 equals log 101. So that'll help you with that. So you'll want to divide by log 3 and then subtract 4. So I gave you a little bit of a hint there with that one. Okay, so now we're talking about this change of base formula. I mentioned it earlier. And it's very convenient for us to have a change of base formula because it makes solving easier. But, and I'll go back to that in a second. But one thing I want to remind you of my forever example here. I'm using log base 2 of 8 because it's a base 2, and even though we can't plug it into the calculator, we know that the answer should be 3. We know the answer should be 3. And I want to show you how this change of base formula works. Basically, you have to figure out what B is and what C is, okay? So I kind of color-coded it for you here, but B represents what I call the old base, and then C would be the new base. So for example, right now, log base 2, that's the old base. I want to convert the 2 to something that my calculator will work in, which is base 10, right? So that's what I've done here. And according to this formula, if you take log base 10 of the original number and divide it by log base 10 of the old base, then you should get 3. So I'm going to go to my calculator, I'm going to go log of 8 and divide it by log of 2, and I get 3. And right now you should be doing that with your own calculator, so not just believe what I say, but you should actually try it on your own. But in fact, you do get 3, okay? So that's how you change bases. Now going back to the original problem that I had done earlier, you might have noticed that we did it a different way, but at the end of the day, when I get my final answer, I got log 20 over log 7. I kind of want you to focus on this piece right there. Log 20 over log 7. Well, the old base was 7. Okay, if you remember, I told you guys that one way to solve this is to rewrite it into log form. And that would be to go log base 7 of 20 equals 3x. Remember that? And this is a base 7. And we said that you can't solve this with your calculator because we don't have a button for log base 7. But if I were to convert log base 7 of 20 with the change of base formula, it would be log base 10 of 20, which you see here, divided by log base 10 of 7, which you see on the bottom. So it's actually, you end up with the same process, but you just get it a lot faster this way. And of course, we divide by 3 to get rid of the 3 there, and that's why you have the 3 on the bottom as well. So just showing you that it is the same thing. So now we're going to, now that we know the change of base formula, we're going to solve a couple of these problems here, and you can see how it works out. So it wants us to use the change of base formula to evaluate log base 3 of 15. So here's log base 3 of 15. And so to evaluate it, that means that I actually have to find an answer. And I can't find an answer with the base 3 because, again, I can't plug that into my calculator. But I can change it to a base 10. And so my old base would be 3, and my new base would be 10. And the formula basically is a ratio of 2 logs. And the 2 logs are going to have the new base. So no more base 3, but now they're both base 10. And the top is pretty much the same as the original problem. It's still 15. And the bottom is the log of the old base. So the old base was 3, so I put that in there. So now when I go to my calculator and I hit log base 15 and divide it by log of 3, I get approximately 2.465. Okay? Hello, Mr. Moore.
Hola.
So that's how I get that little guy. I'm good, thank you. So then it says that the first part is to evaluate it. That's what it equals, approximately 2.465. So the idea here is that if I took 3 and raised it to the 2.465 power, I would get 15. So now I want to convert log base 315 to a logarithm in base 2. In base 2, that means that I'm going to go, instead of having log base 3, it's going to have log base 2. So now my new base is 2, and my old base is 3. So I'm going to go log base 15. Remember, they're just trying to get you to have some practice with changing the bases, that's all. Okay? So if I want to convert from a base 3 to a base 2, I'm just going to, remember the top is the same, so it's still 15, and the bottom is log base 2 of the old base, which was 3. So you get that. Log base 2, 15 divided by log base 2 of 3. And that is how you convert it to a base 2 or whatever. So there you go. Okay? So that's that, guys. So now we want you to try this one. And then we're going to actually solve some exponentials here. So in this case, we're going to rewrite it in logarithmic form. Okay, so again, I always like to put this here because it just kind of helps you see what's happening. Log base 2 of 8 equals 3. So I kind of want to show you how that works. So the base in this case is 2, so we're going to use a log. It's going to be base 2. The 3 is the exponent of the exponential. So the exponent of this exponential is 3x, so it's going to equal 3x. And the 8 is what the exponential equals. So the exponential equals 172, so we're going to put 172 here. So basically we get log base 2 of 172 divided by 3. But we need to convert this, to get an actual answer, we need to convert this into a base 10. So furthermore, I'm going to say log 10 of 172, remember it's the same as the original, divide that by log of 2, log base 10 of 2, okay? And then all that is divided by 3, okay? So go to the calculator, and we're going to go log 172, and divide that by log 2, and I get roughly 7.426, and then we're going to divide that by 3, and your final answer will be 2.475 approximately for that little guy. Alrighty? So I want you to solve this little guy the same way, and then we're going to do this little guy. And example 4 is interesting, and I'm going to have my little friend over there help me out here. Example 4 is asking us to solve the equation but using a calculator. So I am going to roll this this calculator into here. I apologize if you won't be able to see this as clearly as you would like. The board is going to make it a little difficult to pick up on the screen. But hey, oh no, this is horrible. Hold on, sir, it's not your fault. I do believe this is going to be horrible if this is the case. It looks like the bulb just died.
Oh. Are you serious?
Yeah, I'm serious.
That like never happened.
I know, but see, if I turn it on, there's no light. It's not even turning on, there's no light. I just tested this before we started and it did not work.
It wasn't me.
That's horrible. So that means that I won't be able to show you how to do that on the calculator. So I am going to walk you through it. It's not really that complicated, but I'm going to walk you through it. So sorry, Joshua, we're going to have to leave the screen up here.
Oh, man.
But when you graph with the calculator, I'm just going to walk you through the step. What you want to do is go to your calculator, and in Y1, when you go to your Y equals menu, in Y1, I want you to type in 6 to the 2x power. You're probably going to use a little caret key, parentheses, 2x, close parentheses. you want to type that into y1, and then into y2, you're going to type just the number 1500. So basically you're typing the two sides of the equation into your y1 and your y2, and then we're going to use the calculator's intersection feature to actually solve this. Now if I had, I can graph it here on my calculator. I'm going to put in here 6 to the 2x power. I'm going to try to see if I can put my calculator really close to the video screen, and then you guys can see what I'm talking about. Let's see if this works. This is kind of funny. Not sure you can see that. It's kind of having an issue focusing there, but there you go. So I'm going to type in those two equations, and then I'm going to adjust my window because, as you can see, wow, I have all kinds of visitors today. I'm recording, but anyway, so as you can see, you're going to graph this little guy, and you're going to end up with an exponential that's going to look something like this, and a linear equation that looks like that. And we're trying to find where they intersect. So what I'm going to show you next is there's no way you're going to see the number 1500 if your window is at 10. So the next thing we're going to do is we're going to adjust our window, and we're going to go from, oh, I don't know, 0 to, let's go from -10 to +10. And then we're going to go by ones, and then we're going to go on the y-axis. We're going to go from maybe, I don't know, -500 to 2000. And I'm going to go by 100. So again, I'm going to show you my screen here. This is really weird. Sorry about that. I hope you can see that. That's my window. And then I'm going to hit graph. And let's see if I can put this in here. You can see now that there goes the exponential, and there's the horizontal line. And now I'm trying to find where they cross. So the steps for where they cross is for you to hit second, trace. So we're going to go with the second button and then the trace button. And when you do that, you get a nice little menu of different options. And we're going to go with option number 5, which should say intersect next to it. So we're going to hit option 5. And then it's going to ask you a series of questions. And you are going to confirm by hitting yes, by hitting the enter button. So the first thing you'll see is y1 in the top left corner of your screen right about here. It should say 6 to the 2x. So you confirm that it's correct by hitting enter. So we're going to hit enter. And then it should say y2 equals 1500 up in the top left. And you confirm by hitting enter again. And then the last thing you want to do is it says guess. It's asking you for permission to guess. And you say yes by hitting enter a third time. Okay? And when you've done that, you will see at the very bottom of the screen the answer to the problem. That the intersection, the x-coordinate, is roughly 2.041. That is roughly the x-coordinate where these two functions intersect. And that's basically the solution. Okay, you could confirm that algebraically if you wanted to. So I really hope that that was helpful. I'm sorry that I couldn't show you with the calculator screen. But I would like you to try this one by graphing. So follow those steps and you can do that one. And then we're going to go backwards now. Now we're going to solve a logarithmic equation. So if the inverse of an exponential is a logarithm, then the backwards of that would be true as well. The inverse of a logarithm is exponential. So again, I remind you that you have log base 2 of 8 equals 3. That's the logarithmic form, which is what we have. And we want to write it in exponential form. So 2 to the third power is 8. It's actually helpful sometimes for you to actually write the little arrows. Because first of all, this doesn't have the base written in. But if it's not there, we assume it's a 10. So I'm going to write it in there. And we're going to go 10 to the 5th power is 3x plus 1. And that is how easy it is to solve logarithmic equations. It's just to get rid of the log by writing it in exponential form instead. So that means 10 to the 5th power equals 3x plus 1. And now this isn't so bad. You can do 10 to the 5th power. It's a really big number. Let me get out of here real quick. 10 to the 5th power is a million apparently. 100,000. Okay? And then you just solve like you normally would. Subtract 1, divide by 3, divide by 3. So 100,000 minus uno, and then divided by 3 is basically 3, 3, 3, 3, 3. 5 threes. 33,333. And that's the answer to this logarithmic equation. So it's not really complicated as long as you write it in exponential form. It makes it a lot easier. Alrighty, so you can try that one. And I think, oh, I have one more. So after you try that one, then I'll do one more. And then I think we're going to be done with this video. So in this case, what you're seeing is that you've got two separate logs. And so before we can get started with solving, you want to make sure that you only have one log. Well, good thing for us that in the last section we learned how to condense logs. So you want to use our properties of logarithms to condense it to one logarithm. So this is going to be log x squared because of course the 2 in front goes to the exponent. So it's log x squared minus log 3 equals 2. And then when we have a subtraction, that becomes division. It's a quotient. So now I have log of x squared divided by 3 equals 2. And again, we do not have a base, but if it's not there, we assume it's a 10. And then we can use what I was telling you earlier and go 10 to the second power equals this. So to write it in exponential form, I'm going to go 10 to the second power equals x squared over 3. So 10 squared is 100. And to get rid of the divided by 3, we can times by 3 on both sides. So 300 equals x squared. And then we square root, and we get our answer, the square root of 300, which is 10 root 3. If you will remember how to break down square roots, I'm running out of space here. The square root of 300 is the same thing as the square root of 3 times the square root of 100. And the square root of 100 is 10. So we get 10 root 3. And because this is, you square root it, you have plus or minus 10 root 3. And at that point, those are your two solutions, but you should check them for any extraneous solutions because sometimes they don't always work. But for example, we already know that the domain of a logarithm is that you can't take a log of a negative. So see here where it says log x. If I allow x to be negative 10 root 3, I won't be able to do that because it's not in the domain. So after you check your two solutions, the only actual solution that you have is positive 10 root 3. So make sure that you check your solutions in the original equation before you say I'm done. All right, so now we're going to have you try this one. And once you've done that, you will have completed the lesson for today. And I will see you in class. And good luck.
God be with you.